The topic of today's presentation is enzyme inhibitor. So, inhibitors, they are the chemicals that reduce the rate of enzymatic reaction, and they are usually specific. They work at low concentration. They block the enzyme, but they do not usually destroy it. So, due to the blocking of the enzyme activity, it can kill a pathogen or it can create a metabolic imbalance. So, many drugs, they are actually by nature, they are the enzyme inhibitors. So, the enzyme inhibitors, they are broadly classified into two groups. One is irreversible inhibitor and second one is the reversible inhibitor. Again, the irreversible inhibitor, that is the type of the inhibition which cannot be easily removed out, but the reversible inhibitor is the type of the inhibition which can be easily removed out, and it is of the three type. One is competitive, second one is non-competitive, and third one is uncompetitive. Now, irreversible inhibition, the binding of the inhibitor with the enzyme, that is covalent bond. Similarly, in case of the reversible inhibition, this is non-covalent bond. So that's why it can be easily removed out. Now, the three different types of the competitive inhibition that can be easily separated or distinguished by Michaelis-Menten equation or Lineweber-Burke kinetics, that is by measuring the value of the Vmax and Km, where Vmax is the maximum velocity or maximum reaction rate and Km is called the Michaelis-Menten constant. So we have to compare the values of Vmax and Km both in presence and absence of the inhibitor. Now, in case of the competitive inhibitor, the inhibitor molecule, it has some structural similarity with the substrate molecule. So that's why there is always a competition between the substrate and the inhibitor molecule. So there will be the increase in Km value, and as Km is inversely related to the affinity, so that's why with increase of Km, the affinity of the substrate to bind with the enzyme decreases. So this is the nature of the plot when we are having the Michaelis-Menten form and when we are having the Lineweber-Burke plot. So in case of the competitive inhibition, the value of Vmax, it remains unchanged, but the value of Km, actually this is 1 by Km. So that's why we can ultimately interpret in terms of Km, that means Km is increased. So that's why the substrate affinity towards the enzyme, that is reduced. So in case of the non-competitive inhibitor, the inhibitor molecule can bind with the enzyme substrate complex or it can bind with the enzyme molecule. So it will reduce down the value of the Vmax. So in the Lineweber-Burke plot, here we can see that the red one is the for non-competitive inhibitor, and here we can see, as this is the value of one reciprocal of Vmax, so 1 by Vmax is increased, so that means Vmax value will be reduced. Similarly, in case of the uncompetitive inhibitor, the inhibitor molecule, it will bind with the enzyme substrate complex. So in this case, both the value of Vmax and Km, these are reduced. So if we plot the Michaelis-Menten equation and Lineweber-Burke plot, so we will see this red one, this is the characteristic of the kinetics of the enzyme in presence of the uncompetitive type of inhibitor, where we can see that both the values of Vmax and Km, that are changing. So with this, I am ending my presentation on enzyme inhibitor. Thank you.